Hi, welcome back to the second video for the chapter 4 practice test. We are on problem 4. The school store sells book covers for $4 each and the notebooks for $1 each. Antonio has $13 to spend. The function y equal to 13 minus 4x represents the number of book covers x and the number of notebook y he can buy. Select whether each statement is true or false. Okay, so first of all, we need to underline the keyword here. We know that $4 for book covers is $4 and notebook is $1. And the function is y equal to 13 minus 4x. And sorry, I missed the Antonio has $13 to spend. So beside that, they also indicate for you the book cover is x and the notebook is y. Okay, so we need to it's pretty much the problem already give you the whole function y equal to 13 minus 4x, and they tell you x is the book cover and notebooks is y. So the first statement, he can buy 1 notebook and 3 book covers. So book covers is x equal to 3, and notebook is y equal to 1. So we want to check is this point is a part of the solution. We're going to do plug it in. So y is 1, 13 minus 4, x in this case is 3. Will they give you the true statement when you plug it in? So that will give us 1 equal to 13 minus 4 times 3 is 12. 4 times 13 minus 12 is 1. This is true statement. So it will tell you this is true. Okay, we're going to do the same thing for the second statement. He can buy 0 book cover and 13 notebook. So make sure book cover is x equal to 0. And y equal to 13. So we're going to do the same thing. Y equal to 13 minus 4x. This time y is 13 and your x is 0. So 13 equal to 13 minus 4 times 0. Okay, so that will give us 13 equal to 13 minus 4 times 0 is 0, so 13 equal to 13. This is a true statement, so the answer is true. And last one, he can buy 2 notebooks, so y equal to 2. And 5 book covers, so x equal to 5. Y equal to 13 minus 4x, y is 2, x is 5. So 2 equal to 13 minus 4 times 5 is 20. 13 take away 20 is negative 8. This is a false statement, so it's wrong. It's false. Alright, so it's quite obvious that the book cover is $4 and he bought 5 times 4 is $20. But in fact, he just have $13 to spend, so it's way more than what he has. So this is not true. If you think it based on what they're telling you. Okay, number 5. Roger earns $8 for every hour he babysits. So complete the table order pair to show the total earning for several hours. So we talk about this, but we've been practiced a couple problems like this before. So Roger earned $8 for every hours. So means this is what he earned consistently, the same amounts of money over time. So M equals to 8. And they didn't say anything about his flat rate or his earning, how can I say this? His base fee. The fee that people pay him even not working any hours. So we assume that it's going to be, if he doesn't work, he's going to get $0. And for every hour he get paid is $8. So B going to be 0. Y equal to mx plus b. So y equal to m is 8, x plus 0. or basically y equal to ax. So our next step is plug in all the value that they given you. So y equals to 8 times 1 is going to be $8. And y equals to 8 times 2 for 2 hours is going to be 16. Y equals to 8 times 3 is going to be 24. That is $24. And last one, y equals to 8 times 4 hours is going to be $32. Okay, so we're going to use this to do part B. What would his total earnings after working 17 hours? So same thing, we're going to plug in 17. Y equals to 8 times 17. Okay, 17 times 8. 8 times 7 is 56. Remember 5. 8 times 1 is 8 plus 5 is $136. What would he total earning after working 17 hours? So it's $136. Alright, number 6. Describe the type of function that have different characteristic. Part A. Describe whether each is a linear or nonlinear, and clearly state what type of function is represented. Okay, so first of all, linear function is the function has the power no more than 1. So basically, linear function, and beside that, linear function is a straight line. So based on the problem that they give us, this problem has x squared. So it's not a linear function because of the square. This calls quadratic function. Okay, describe where it is linear function. Okay, this is not a linear function. This is not a linear function because the variable has the power greater than 1. Okay, what type of function it is? Because of the powers is 2, it is a quadratic function. It is a quadratic function. Quadratic function. Alright, part 2. This is a linear function. This is a linear function. Because the graph is a straight line. Okay, so that's it. Okay, the next one, y equals to 1/2 x minus 1/5. So again, because the variable has the power of 1, so it is a linear function. This is a linear function. This is a linear function. Because the variable has the power of 1. Okay, and beside that, they also in the format of y equals to mx plus b as well. Alright, last one. Is this one a linear function? So what we're going to do is the table, so we're going to check the pattern. 0 to 2 is adding 2, 2 to 4 is adding 2, 46 is adding 2. For the y value, 5 minus 2 is 3, 3 minus 3 is 0, and 0 minus 4 is negative 4. So as we see that linear function is a straight line, they're going to follow exactly the same pattern. They were increasing and decreasing consistently with the same amount of number every single time. So since the y value in this case is decreasing inconsistently, the first number is decreasing by 2, the second number decreasing by 3, and the third number decreasing by 4. They have the pattern, but they don't increase. They have the pattern, but it's not decreasing consistently, so it's not a function. This is not a linear function. Because the y value decrease inconsistently. Okay. Alright, part B. Choose a nonlinear function from the above and describe how could you change the representation that is nonlinear function to make it linear. So it's pretty much easy. Problem 1, we say that is quadratic function because the power is 2. So we just need to do is change it to the power of 1. Y equal to 0.7 x squared minus 8. The y equal to 0.7 x squared minus 8. How can I say this? Change. Okay, can be changed as a linear function by changing the second power to the first power. Okay, I'm not sure if it's clear what I've tried to say, but I want to say is y equal to 0.7 x minus 8. This is a linear function. Okay, that's it. The second thing we can say, or the other function that we can change is the last problem, the table. We can say that we can change the y value, all the y value. We can change all the y value by take away 2 for every single box. We can change the number as 5, 3, 5, 3, 1, and negative 1. So which means you take away 2 every single time. Alright, we come to the last problem. Renee makes the conjecture, so kind of make a conclusion. The graph of any absolute value relationship in V shape represent a function. So basically he said that all the absolute value relationship would mean any graph with the V shape is gonna be a function. So which graph provide the counterexample for Rodney conjecture and clearly explain your reason? Okay, so we know that the linear function, or a function in general, let's say a function, when a function is the relationship that every input will have exactly one output, which means every x value just have only one y value, one corresponding y value. So there's another way to say this is the vertical line test. If you draw a line that it just only cross the graph as one point, then it is a function. For graph 8, if I draw a vertical line, you see that they cross the graph as 2 points every single time. So this is not a function. Why? For example, this point is x value is 4 and corresponding y value is 4. However, it also have another corresponding y value is negative 4. That's why it's not a function. For graph B, if you draw a vertical line, they only cross your graph one point at a time. So this is a function. This is a function because they cross one point for every single line. And part C, if you draw a vertical line, they just cross the graph as one point every single time. Okay. I will say, okay, clearly explain the reason. Okay, I would say Rodney's conjecture is incorrect. The graph A is not a function because it's failed the vertical line test. For example, x equal to 4 has two corresponding y value, which are 4 and -4. Alright, and I believe, yes, that is the last problem. I hope that you will study well. Make sure you take notes. For my class, you're allowed to make a flashcard. If you have any question, you can ask me in class and we can go further on this practice. Alright, good luck everyone.